For this session, feedback link available in the chat box. You can fill it. Within few minutes, we will start the next sessions. Participants are requested to stay back and join the next sessions. Sorry, Welcome, Dr. Vinod Kumar, sir. I welcome to this session. Dr. N. Vinod Kumar is a distinguished professional renowned for his significant contribution to innovation, manufacturing, and research. Currently, he is serving as a proprietor of Vimal Innovations and Manufacturing System, Madurai, India. The company focused on innovation product development and advanced manufacturing solutions. With a solid foundation in both academic and industry, Dr. Vinod Kumar has contributed to groundbreaking research at the Compact Vehicle Research and Development Establishment under DRDO in collaboration with Kalasalingam Academy of Research and Education. His expertise spans product innovation, defense technology, and industry integrations, reflecting his commitment to advancing technology and excellence in researches. He is not limited. He is continuing his research in the contribution through his own companies. I welcome sir to this session. The session is yours, please.
Thank you, sir. Thank you. Thank you for the nice introduction. I heartily thanks to NPR College of Engineering. Myself, Dr. N. Vimal Kumar. Today we talk about, first of all, good evening to all. Thanks for attending this event. So today we talk about measurability studies on HSLA steel by using abrasive water jet machining process. So in my community, 3 segregation works are going. First one is research and development, innovative research and publications, engineering projects, mechanical and automobile, patent support and develop prototype. Second one is academic programs, research-based guest talk, self-development program, agriculture technology. Third one is the agri-based work, the nursery plants and farm consultancy, farming of monosyllable flowers, festival garlands, and event management. Now we go to top. These are the ongoing projects, research-based, publication-based also, patent-based also. Now we talk about measurability studies and HSLA steel by using abrasive water jet machining process. So my voice is audible? Hello? Sir, my voice is audible?
Yes, audible, sir. Please.
Can I continue with this slide?
Yes, sir. Please continue, sir.
Anyone please respond?
Yes, sir.
Yes,
Yes.
Vimal Kumar, audible, sir.
Thank you,
You continue,
thank
sir.
So now we, yes. So measurability studies on armor grade steel. Yes, sir. Thank you. Measurability studies on armor grade steel plate ASI 4130 in abrasive water jet machine. Now initially we talk about HSLA steel because in HSLA steel various grades are there. So now we choose about a specific grade. It is also one of the HSLA steel. The name is ASI 4130. It is also called armor grade steel or EN24 grade steel. It is very specially used for automotive frame applications, defense technology also, defense frames also. They used for this ASI 4130 grade. So now we talk about now onwards we talk about HSLA steel into armor grade steel because both are same. Because we taken about ASI 4130 grade steel for this conversation. So armor steel is a quenched and tempered steel is to form of road homogeneous armor steel is in diverse applications. It have a Martin stick microstructure in body center tetanal crystal structure. Generally, it is prepared by quenched and tempered process. The quenched is nothing but it is heated up to 900 degrees Celsius at 1 hour time. The armor plate, the temperature of armor plate, minimum temperature in the range of 2 degrees Celsius at the 2 hours time duration and cooled by air temperature. In this condition, armor grade EN24 steel is converted into armor grade steel. It means mechanical property and microstructural categories also changed with the higher values. So in this condition, weight to strength ratio is increased as compared to normal grade steel. In combat vehicles, generally called the full form is tracked armor navigation cart, is a firing vehicle and it is widely used in defense applications. It has a high strength to weight ratio. I already told that because of the quenched and tempered condition heat treatment process, the normal grade is converted into high strength steel with concerning the applications. So HSLA steel is one of the grade is armor grade steel. These are the thermomechanical properties of armor grade steel. So mass density, shear modulus, Young's modulus, Poisson ratio, thermal conductivity, melting temperature, specific heat capacity, thermal expansion. So these are the values are also increased with respect to heat process of process condition. The armor grade steel of thermomechanical properties are satisfy the requirements of combat vehicle. As per the literature, the Gurujik et al. 2013. So ballistic properties of armor grade steel. So it is also bulletproof material because of high strength to weight ratio. The armor grade steel is good ballistic performance in combat environment as per military standard. The military standard I will share the code in behind the slides. It is used to save the soldiers from enemies attack in a combat environment through missiles and emulsion. So structural application is combat vehicles. So these are the combat vehicles. The Arjun tank, the name is, it is also currently used in Indian Army. So it have three categories of this vehicle segregated into three categories. The top one is the turret, that is soldier place. The middle one is the hull part. It is saved by the emulsion. The bottom one is the tracked wheel, road wheel with attached track. So it is a chain based movement. So advantages are resistance to penetration and shock absorption, high strain rate, high strength, high harness. The high harness is the value of greater than 370 HE. So somebody told that it is armor grade steel, but how do we confirm this is armor grade steel? So some technical measurement is there. This is the one of the technique, spectroanalysis. So spectroanalysis is used to measure the chemical compositions. In this composition, we easily identify each chemical composition is coming under some categories. This is stainless steel. This is aluminum alloy. So aluminum alloy having some specific composition. So this spectroanalysis is used to help to measure the chemical composition of our HSLA steel, specifically in armor grade steel. So in this condition, higher heat is applied to the material in the closed environment in the testing machine. At that time, several colors is reflected inside the machine. So in this condition, the color changes. We can use this color changes and this easily evaluate the chemical composition. This part is coming under full and full doing the machines only. So that machine is called spectroanalysis, the testing process. It is also we currently tested in Kiddo Laboratory, Chennai. These are the chemical compositions. These are the several armor grades are there. RMAX 500, military standard A12560, RHASS, MIL A4610, PROTAC 500, ASI 4340, HSS, HSLA 65, high harness armor steel, HSA. These are the several grades of armor steels also there. Basically, armor steel is a one of coming under one of high strength low alloy steel. In this condition, specifically armor grade steel he prepared by heat treatment process, constant tempered process. In the heat treatment, several categories is there. Varying the temperature with respect to the specific component of the combat vehicle. So in this condition, several grades of armor steels are prepared by Indian Army. So in this, as per the schedule, these are the several categories I mentioned in the chemical compositions. So these chemical compositions are prepared from our literature only. These are very preserved one. So not for all countries, this is not visible. The chemical composition of the armor steel. So based on the chemical composition changed in the condition, the mechanical properties also changed. The mechanical properties in the sense yield strength, ultimate strength, harness, elongation. These strengths, these values are changed with respect to each grade of armor steel. Each grade of armor steel varying with respect to chemical composition and mechanical properties. So chemical composition is related directly proportional to the mechanical properties. So mechanical properties directly proportional to the microstructural studies. So initially we totally see the base materials, armor grade steel. Okay, armor steel is one of the high strength low alloy steel. So why we go for machining? Generally, each steel is prepared a rolling sheet or coil or rod, whatever is a raw material only. Now we go for application. We need to prepare some of the safe with concerning the applications. For example, it's a defense application. In the condition, we need to prepare the vehicle, tank vehicle. In this condition, the tank vehicle, they used 12 thickness into 150 thickness. They used approximately tank weight of the tank is 100 tons. The cost is also per vehicle cost is 120 crore. Our Indian Army expenses up to 120 crores for the one vehicle. So in this condition, in each country, they give a more important for the defense vehicles. So in this condition, they need to cut the specific dimensions from the raw material, and then it will convert it into a second manufacturing process. It's called welding. Then it go to finalize the military vehicles. So in this condition, machining, generally they use the flame cutting process. In this flame cutting process, they involved maximum heat. So in this condition, base material properties also changed. We need to understand that in each material we need to prepare as per the applications only. At that in that manufacturing conditions, if we involve maximum heat, that material properties also deformed in the condition we can't use. It is not perfect fit for the specific applications. So in this condition, we need to go for non-conventional machining. The non-conventional machining in the condition abrasive water-jet machining. In this condition, maximum heat is not involved, because water only involved to cut the material with the good surface finish also. We need to how to it will involved the flame cutting and water jet machining, how to involve in the armor steel for machining process. We will learn about in the further slides. These are the facilities available related to activity. Generally, abrasive water jet machine, these are the specifications. It is available in Kalasalingam University. After cut surface, we need to see the microstructure. So in this condition, we need for some unit. Afterwards, physically we need to measure the surface values with the help of surface roughness tester. Generally, most of the institutions use the Mitoyo SCA410 model to measure the surface roughness of the cut surface, the measuring surface material. This one is the abrasive water jet machine. Here, this one is the heart of the water jet machine, ultra high pressure pump. This was the 35 HP pump. It is converted into high pressure water. So this is the basic source. This is the heart of the abrasive water jet machine. Then this is the water jet bed. This is the Z axis and XY axis movement. TWJ 1313 FB. This one is the abrasive water jet model. This company is located in Ahmedabad. In backside, the coolant motor also there. There is called the chiller plant. Then servo stabilizer also is there. There is the control panel. The control panel is generally we use the FANUC coding, G01, G02, reverse direction, front XY direction. In this condition, we need to specifically cut the material by using abrasive water jet machine. This is a very safe cutting process, because no heat is involved in this cutting process. At the same time, very safety equipments are there. If any issue is there, for example, the nozzle is touching the any outer surface of the machine bodies, at the time the alarm is indicated and the control panel is stop the whole machine process. So in this condition, no defect is there. Very easy machining process, but cost wise is high, but as compared to quality, the cost is not high. That is the reason. So here various kinds of metals, ferrous and non-ferrous, such as steel, MS, brass, copper, alloys, aluminium, stone, rubber, compounds and glass can be profiled with ease. So I will show them video. Afterwards, I explain means then you are easily understand about the advantages of the water jet machine. Actually, we are doing 20 thickness machining process to do the project in DRDO in 2019 to 2023. But they don't know about it is how much thickness it may cut. They don't know, because we get the challenge from the DRDO people's scientists and get the 80 thickness plate. This one is the 80 thickness plate. but we have a basic water jet machine. So we tried for number of trials and we fix the we will optimize the cutting parameters and we finalize the one specific parameters, and then we will get cut the materials successfully. So I will play the video. See, this is the cut surface. We are initially started with the trials, number of trials. In this trial, this is not a perfect cut, because these are not a proper cut. This was a very thin cut. This one is this not penetrated in the depth, because 80 mm thickness is not a easy one. It's a very biggest one. At the same time, it is a bulletproof material also. So we need to get struggled with this cutting process. After a number of trials, we get find out the issue, and we clearly cut the good finish of 80 mm thickness plate. Yes, this video is over. We need to understand that this one is the nozzle. The high pressure water is coming under this direction. Additionally, the upper of the nozzle abrasive also joined with this pressure water. In this condition, high strength materials also can cut easily. Generally, water jet machine can cut glass, wood, anything, but if we need to cut the steel or high strength materials, we need to add the abrasive into the high pressure water. So abrasive plus water is used to cut the high strength steel materials. Here two kinds of abrasives are used. I will tell. So these are the abrasive water jet machine parameters. First is the traverse feed. The range is it is specifically designed for armor grade steel. Because we need to thick the high strength material, we need to reduce the feed rate. Then only we can easily cut the depth of penetration. So the traverse feed 5 mm, 10 mm, 15 mm. Pressure is called as is a unit of megapascal, 220, 240, 260. We increase the pressure. For we example cut the aluminum, we set the pressure value of 120, 140, 160 only, because it is high strength bulletproof material. In the sense, we need to increase the pressure also. So pressure means water pressure. This is standard distance. Standard distance is nothing but cutting material into the nozzle tip, the gap between the nozzle tip and the cutting materials. So abrasive mass flow rate. Abrasive mass flow rate in the sense 310 gram per minute. This is also moderate value. 310 gram per minute is the moderate value. And abrasive size. The size is the Garnier 80 mesh, 177 microns. The particle of the abrasives. It is also mesh size. 170 diameter is 0.67 mm. The orifice diameter, it is also coming under the nozzle, 0.25 mm. The position of cutting it is 90 degrees. It's a vertical cutting. These are the initial parameters of the water jet machine parameters. So I already told that there are a variety of garnet abrasives used, but we use the silicon carbide and garnet. These are the silicon carbide chemical composition, and these are the properties. These are the garnet abrasive chemical composition and the properties. As compared to silicon carbide and garnet, garnet have a lower values. So we tried with both the abrasives in the water jet machine. So initially we tried with silicon carbide. In this condition, silicon carbide have a high hardness, so it easily cut the armor steel. At the same time, it easily affect the surface. So it is not get the good surface finish, because it is a high hardness. High hardness in the sense it is easily affect the surfacing materials. So next we go for garnet abrasive. So it is SEM images. See, easily some traces are identified easily from using silicon carbide materials. This is a silicon carbide powder. It's a look like ash color. So next we go for abrasive. Garnet abrasive. Garnet harnesses high, very less value as compared to the silicon carbide, but finishing is good. See, this is the 500 magnification, 500x magnification. There is very little rate of traces are we identified, but it is the maximum magnification. So this is armor grade steel for cutting water jet machine. Garnet abrasive is a very suitable one, as we find out in our research. This is a comparison. This is the silicon carbide flame cutting, silicon carbide water jet machining process. These are the garnet abrasive water jet machining process. By using garnet, this is the good surface finish we achieved. So this is a common principle for water jet machine. Generally, we used to cut the material by using abrasive water jet machine. In this condition, several kinds of cut surfaces we identified. So straight cut, taper cut, positive cut, negative cut. So there are several categories of cutting is we identified as per with respect to the water jet machine parameters. But the straight line cut is the perfect one for the cut surface. It is get by very suitable machining parameters. The suitable parameters we get by number of trials. Each material having different categories of machining parameters by using water jet machine. This one is the nozzle. So nozzle is produce high pressure water. The high pressure water is mixed with abrasive. So in this condition, it will cut the high strength materials. So this is the water jet machine parameters: water, pressure, traverse speed. In the traverse speed changed in the condition, there are several kinds of cut surface we identified. So this is the first one is the correct taper. Second one is the positive or reverse taper. Third one is the negative or weak taper. Fourth one is the barrel taper. The water jet machine parameters not fit for the materials. We can get the second, third, fourth kind of shape cut surface materials. If we choose the correct cutting parameters, definitely we get the correct taper in the cut surface material. And third one is the standoff distance. Fourth one is the abrasive flow rate. Abrasive flow rate in the sense garnet flow rate. So measurement of measurability performance in abrasive water jet machine. So this is the 20 mm plate is cutted by water jet machine. So these are the output parameters, kerf angle. So kerf angle is nothing but cut surface of the material. How much is angle deviation is occurred in the cut surface. It can easily find out by kerf angle. The kerf angle formula is theta is equal to WT. WT is nothing but top curve width. So this is the top curve width, this is the bottom curve width, and T is the thickness of the material. T is here called 20 mm thickness. So from the each trials, we can find out the kerf angle. When the kerf angle is very minimum level, so that is a suitable parameter for that material. Is the very easily understand. These specific parameters we identified from the number of trials only. So that is the best one and the practical acceptable one. Second one is the material removal rate. Material removal for water jet machine is calculated based on the depth of penetration, kerf angle, traverse speed. So here MRR is equal to HT/DIF. HT is equal to depth of penetration, D is equal to kerf width, F is equal to traverse speed. In this formula, we can easily find out the material removal rate of the water jet machining materials. So here we can choose the here cut the 12, 16, 20 mm armor place. Machining of 12, 16, 20 mm armor place. Here 27 L27 parameters. SOD feed pressure. We changed the 27 variations and the output of the kerf angle, material removal rate, surface morphology. Because why we choose for 12, 16, 20 mm in the sense, armor shield 12 mm we used for the bottom plate, 16 mm and 20 mm used for the hull part. The hull part is the center part of the tank vehicle. So these plates are covered the tank frames. So in this condition, machining condition, the higher heat is involved in the sense the material properties also changed. Material properties changed in this condition. If enemy give the fire means the bullet is easily penetrated to the mechanical property changed material. In the sense, our research materials, if the our materials mechanical property changed by using the machining process, the bullet is easily penetrated to affect the soldiers. So in this condition, we do not affect the base material properties. At the same time, we need to cut the good surface finish of materials. In this condition, we go for abrasive water jet machine, and the material choosing for 1216 mm is based on the applications. This is the methodology of Kirchhoff measurements in the 12 mm plate. These are the various L27 cuttings, 12 mm, 16 mm, 20 mm. From this each cutting, we can measure the top curve with bottom curve with T3 values and get the average values, and put in the formula. We can easily get the kerf angle values for 27 readings. It is specifically based on the 12 mm plate. So similarly, we can calculate the 16 mm plate and the 20 mm plate, because both 27 variations of input values are same. So we can calculate the input and output parameters of the 12 mm, 16 mm, 20 mm plate of armor plate for the defense application materials. This is the kerf angle. This is the easily understanding about the kerf angle measurement. It's the top curve with we can 3 readings, and the bottom curve with 3 readings. We can take the average values and put in the formula. We can easily get the kerf angle. Here kerf angle is 0.2309 is the value of this specific cutting process. We need to reduce the 0.1 is the very good one. So we can already we tried with the L27 parameters for 12 mm, 16 mm, 20 mm plates. From the all readings, I will show the output values. In this condition, whenever the kerf angle is very minimum level, that is so that the input parameters is very good one. I will show in the next slide. So this is also material removal rate formula. So material removal rate is equal to total. The formula is there 16 into the thickness of the material, then 0.8835 in the 8. So material removal rate is equal to 70.68 millimeter cube per minute. So we using this formula and put the values, so we can easily get the material removal rate formula for this measurement. This measurement is easily measured by the images software. We can capture the image and put into the images software. It will convert into pixel into mm value. So generally we capture the picture means it is always in the pixel value. So images software is converted into pixel into mm value. Then only we get the top curve with the value in the mm, bottom curve with the mm. Then put in the formula. Then we will get the answer. So these are the input and output values of the 12 mm, 16 mm, 20 mm plate for 27 trials. So what are the input values? Standoff distance, feed, pressure. So output values is the kerf angle and the material removal rate. The another one also is the surface roughness values. We will show in later. First, we need to understand the kerf angle and MR values for these 27 parameters for the three different thickness of materials. So here, for example, we can see the 12 mm plate of kerf angle 0.16, 0.0023, 0.10, minus 0.40. So we can get the 0.0692, 0.0092. So here we are getting the very minimum level of kerf angles. So here, I think this second one, 12 mm plate, 0.0023 is the very good kerf angle we achieved. 0.00 in the sense, straight line is achieved in the cut surface. So in this condition, SOD1 feed rate is 10 mm per minute, pressure is 220 megapascal. It is suitable for the 12 mm plate, but it is not same for 60 mm, 20 mm plates, because depth of the penetration, the input parameters also changed. For example, we can see the 60 mm of the kerf angle. We can see the 15th serial number 0.222 is there, and the 17th serial number 60 mm kerf angle 0.0089. This one is the good reading. So here 60 mm thickness plate, the 19th reading of SOD3 feed rate is 5 mm per minute, megapascal 220 pressure is good for the 16 mm plate. But 20 mm plate also is varied in the input parameters. We can see the theta value, the theta and kerf angle. Here we can see the 0.02. This one also very good one. we can achieve straight cut. It's a minimum level tolerance only here achieved as compared to other readings. So in this condition, 20 plates also the input parameters are so difference upon the not only for same materials, different of the thickness also, the input parameters also changed in the abrasive water jet machine. So in this condition, the material removal rate also changed because the whatever we give the input, that is the material removal also based on that input also. So that is in this condition we give the input values of the measurement by using images software. That time we will get the different material removal rate for each trials. These are the I hope you are understand that these are the input parameters for the three thickness of material, and we will get the three different values of kerf angle and material removal rate values. So these are the experimental results of correct taper in 12 mm armor plate. In this condition, SOD1 pressure is 220 megapascal feed, because I already told that the second one is suitable for the kerf angle. In this kerf angle, I already also checked with the images software to get the each readings, because this is the 12 mm plate in the sense I can measure with each gap, center gap for the this cut surface. So here I will take the here 12 mm thickness in the sense I will take the 12 readings in the gap between two cut surface. So I will get 12 readings. In this condition, by using images software, the gap between what are the initial value in the first 1 mm thickness, what are the second mm thickness, 3 mm, 4 mm, 5th mm up to 12 mm. I will measure the individual values. Then I will draw in the graph. So kerf width, this is the kerf thickness. So first mm thickness, the value is 0.769. So it is look like straight cut, but we see in the graph it is not in the straight cut. Is some oscillation is there. That is the reason the kerf angle value is I already shown in that 0.0023. Why here 23 coming in the sense in this is the condition. So our eye is not to see the exact value, exact visible in the condition. It is up to we zoom in the condition. This kind of shape is the real we can achieve. So but this is also good because our eye vision is look like straight vision, but our images software you can exactly predict the what is the shape of the cut surface in the 12 mm thickness plate. Like that 60 mm plates also we can measure the each values for 16 readings, and then apply in the graph. We can see the alignment. It is not also straight cut. Some here also some physical curve is there. The cut surface, our eye is identified, eye vision. At the same time, here also see that some angle deviation for each mm thickness of the 60 mm plate. Here SOD is 1 mm pressure, 220 megapascal, feed rate is 5 mm. So this is not suitable for 60 mm plate. So like this same condition 20 mm plate, we can follow this kind of shape is we achieved. It's a negative or V taper. From this reading here also we can measure the 20 readings up to each thickness by images software, and we plot a graph. Here also visible in the what we occur in the exact shape of the cut surface. So it's a experimental results on kerf angle in armor steels 5 traverse feed. Here we can change the traverse feed, but we fix the SOD and pressure. So we can fix the SOD and pressure. We can change the traverse feed. What is occur on the kerf angle? From that readings, we can draw the graph. In this graph, traverse easily identify the traverse feed is increased, change in the condition. Kerf angle also changed. The black color line is the 12 mm plate, and the red color line is the 16 mm plate, and the blue color is the 20 mm thickness plate. Both the plate we can fix with the SOD and pressure, and we can change the traverse feed in the condition. So kerf angle is changed or not. So in this condition, traverse feed is changing condition, and the kerf angle changes in the kerf angle. It is directly proportional to the kerf angle, directly proportional to the traverse feed. If traverse feed changes, the kerf angle also changes. So traverse feed is influence the kerf angle. We need to identify that. We need to must know that traverse feed is play a major role in the cutting machining process of the water jet machine. So in this condition, we can control the traverse feed. We can minimize the kerf angle. This is a best way of understanding. That's why I need to draw this graph. Next, we experimental results of kerf angle and armor steel by approach with pressure. Here, we need to fix the SOD and feed rate for three thickness of plates, and we need to change the pressure. If the pressure value change in the condition, at the same time kerf angle change, it means pressure also influence the cut surface of the three thickness of plates. So here also same. The black color line is the 12 mm plate, red color is the 16 mm plate, blue color is the 20 mm thickness plates. Here we fix with the SOD and feed and can change the pressure. If kerf angle changed or not, absolutely. If pressure changes, the kerf angle also changes. So not only traverse feed, pressure also influence the kerf angle in the cut surface of the water machining process. So next is the standoff distance. So here standoff distance, we need to fix with pressure feed and change the SOD. If SOD changes, kerf angle changes, means the SOD also influence the material. Absolutely, if we can use standoff distance increased in the sense, definitely kerf angle is increased, because for example, we open our home tap, the starting condition will come straight. If you increase the 1 feet or 2 feet, it will come to taper. Like the same condition occurred in the water jet machining process. If we increase in the SOD standoff distance in the cut surface, the cutting of water flow is coming to taper condition. So it is not in the straight cut. So it is also kerf angle is changed. So definitely SOD also influence the kerf angle. So kerf angle is influenced by SOD, traverse feed, pressure. So audience understand that. So kerf angle is controlled by SOD, traverse feed, pressure. So here experimental results on MR material removal rate by aperture traverse speed. Now we talk about previously what kerf angle influence by SOD, traverse speed, pressure. Now we see about material removal rate. It is influenced by traverse speed. If traverse speed changes by three different materials, definitely material removal rate directly proportional to the traverse speed. If traverse speed is increased, material removal rate also increases. So in this condition, black color is the 12 mm plate, red color is the 16 mm plate, and blue color is the 20 mm plate. We can fix the SOD and the pressure input values, and we can change the traverse speed. The material removal also changed in the condition. So here also traverse speed influence the material removal rate. Next, pressure is influence the material removal rate. Here we increase the pressure. That is mostly here not is a reason behind the material removal rate, because here mostly we receive the straight line for the 12 mm and 16 mm thickness plate. For 20 mm thickness, the pressure is influencing material removal rate, because here higher amount of volume is involved with particular pressure in the condition, the material removal rate. But the minimum thickness level, pressure is not influencing material removal rate as per our experimental study. So here standoff distance is influence the material removal rate. Yes, definitely standoff distance is material removal rate, because we increase the SOD, the higher material removal rate is occurred. This is the best example of this graph. So 12, 16, 20 mm plates, we can get the not get the straight lines, we can get the uneven values. So in this condition, SOD is influence the material removal rate. So what we seen in the what is the input parameters? SOD, traverse speed, pressure, the abrasive. These four are the input parameters. What are the output parameters? Kerf angle, material removal rate. Already be seen from the previous slides. Now we talk about another output values, that is called surface toughness values. So these are the surface toughness. So surface toughness value is measured by Mitutoyo, and it is one tip is there. The tip is very sharp and it is traveled into the cut surface of the material. We can get the surface toughness values. For example, we can take into the one trial cutting material. For example, SOD is 1 mm, feed rate is 5 mm per minute, pressure is 220 megapascal. Here 20 mm thickness, 20 mm, 60 mm, 20 mm plate is there. We can measure the three different surface toughness values. Three different in the sense, cut surface of the top, middle, bottom. So we can take into the three values, because the top cut surface surface value is very smooth, because it's a touching point of the water pressure. Afterwards, how it can involve into up to depth of penetration. So here top cut surface and bottom cut surface is not equal because water traces are formed in that cut surface. We can easily identify it in this picture. So in this condition, we can measure the top surface finish, middle surface roughness, and bottom surface roughness for 3 different thicknesses. Here T is the top surface roughness, M is the middle surface roughness, and B is the bottom surface roughness. These are the values of 12 mm, 16 mm, 20 mm plate. These are the average values for surface roughness values: 2.541, 3.143, 2.463. So here 2 is acceptable one, but 3 is not acceptable one because 3 is coming under surface roughness values. This kind of traces are identified in the SEM images. So, but it is not visible in the eye vision. But this is the final X SEM image. Then only we can identify in the water traces. So generally, surface roughness 1 is acceptable one for the cut surface of the water jet machine. We also achieved this for understanding purpose. I prepared this table. So this one is the surface roughness values for 12 mm, 16 mm plate, normal plates. So we are done with 27 experiments for 20 mm plate, 16 mm plate, 20 mm plate. For each thickness, we can trade with 27 experiments. This is the first 9 for 3 different materials. Then second 9 values for 3 different thickness of materials. Then third 9 set of 3 different thickness materials. Here I get various surface roughness values. Here, abrasive armor grade steel is a very high strength steel. So here we get achieved less than 1 surface roughness value. So we conclude that 2 and 2.5 is the sufficient for the armor grade steel because it's a high strength blow-through material in the sense the water depth penetration is very tough as compared to the other materials. So here surface roughness, this is the plot surface roughness measured in the surface roughness machine. Generally, we can measure the top curve, full middle surface roughness and bottom surface roughness. Whenever the surface roughness tip is traveled in the cut surface, at that time this kind of graph is plotted in the machine. From that measurement, finally we can get the 2.157 micrometer, 2.196 micrometer, 2.424 micrometer. These are the values finally concluded from the surface roughness tester machine. If we need to get the graph, we can take the printout of this machine, surface of the machine also. So this is currently this is done by our Kalasalingam Institute. This is a 60 mm plate surface roughness values. So 20 mm plate surface roughness values. It's a comparison of surface machined armor plates. So here 12 mm we can get the best, moderate and worst. 3 different values we can get the 3 different values. Here also 60 mm plate we can get the 3 different surface values: best, medium, moderate and worst. Here also we can get the 3 different values. From the different values we can plot a surface roughness comparison values with respect to pressure. Pressure values increase, surface values increase or not. Here not deviation is occurred, not that much as compared to the material removal rate graph, comparison graph and rectangle graph. Mostly we can get the straight line. So here pressures not influence the surface roughness. Next we go for traverse speed. Here definitely traverse speed is influence the surface roughness values. That would say SOD. Here SOD also influence the surface roughness because the angle is mostly it can most of the is achieved by deviation. Straight line is not occurred. So in this condition, SOD is influences surface roughness. It's a cumulative graph for initial, medium, and bottom of the single plate. Here, 12, 16, 20 mm plate, we get the surface roughness values for each parameters. Here, 2.424 is acceptable one, and 3.234 is acceptable one. Is okay in the condition, but 4.943 in the 20 mm plate surface is not okay. So we can change the input parameters and we get the value of surface of the value in the less than 2 or less than 3, it is acceptable one. Already we tried a number of trials and we also achieved. For this initial stage, we can get this kind of values. So 4.9 is gonna, it is I vision is our vision is easy to identify the number of traces in the cut surface of the water jet machine. Cut surface of the our research materials. So results on one surface morphology of armor plates. So these are the surface influenced by different parameters. The same it's a 20 mm plate. Now we see the some microstructure of the cut surface. Already we seen that is the top surface, middle surface, bottom surface of the 12 mm plate. Whatever we measure the surface surplus values, we can check out in the SEM image. Here, micrometers is 2.157 micrometers we identified in the physically testing equipment of the cut surface, but the SEM image here very minutely see the direction of cut is identified. Here straight line is very minute level of we identified. Here the middle surface, here the bottom surface. Here embedded garnet particles is placed in that top surface. It is SEM image is identified, but it is not fixed in that cut surface of the material. So here 2.157, 2.196, 2.4 is acceptable one because the maximum SEM in the condition, the finish, the visual is very good surface as compared to the flame cutting process. So 12 mm plate. So craters very straightly seen, and the embedded garnet particle, the buffing deformation by spherical abrasive particles. These are because whenever we using the abrasive particles, the abrasive particles influence the depth of the penetration for cut surface, and at that time some minimum heat is involved. In this condition, the particles also is mixed with that cut surface. That's why the white color dotted line is visible in this condition. So the same like 16 mm plate, top surface, middle surface, bottom surface. These are the physical values of the surface values. These are the eye vision. What is look like cut surface of the material in the SEM microstructure for the 16 mm plate, and this one is the 20 mm plate. So optimization techniques. So already we done the research by three thickness of materials in the armor steel for different applications. Now we change the thickness. Again we do for number of trials. For example, 12 mm, 16 mm, 20 mm plates are we used. They give for 30 mm thickness or 40 mm thickness. We tried with a number of trials using it is possible. It's a current scenario. We don't have time to do the research for a repeated task. So what is the sense here? Optimization techniques are involved in the sense statistical tool. It is also called one of the thing is regression analysis. It is used to whatever we get the same grade of material values, that the input is used into different thickness of the material but the same material condition. Because what I'm saying, chemical combustion is same but the thickness is changed in the condition. If we work out with particular thickness, we can utilize that values and we can use the new thickness of the material for the armor grade steel. In this condition, we can reduce the time and we can get the what are the output values we can occur. For example, in the machining condition, kerf angle, material removal rate, surface roughness. I will show in the later next slide. So here these are the already we get the input values, SOD, feed rate, pressure for the three thickness of materials. These are the output values, theta, kerf angle, MRR for 12 mm, 16 mm, 20 mm plate. So these are the another one values, surface roughness values for the three different materials, three thickness of materials. So these are the inputs we need to upload into the regression analysis software, and we can find out we can change the material, we can change the thickness of the armor grade steel what are the output is coming in the sense we don't know, but the software we can easily predict the particular values, we can easily identify. In this condition, research time and the waste of cost is reduced, because we have a lot of schedule is there, and we already we get the some values, means how to utilize to in the futuristical work. So in this condition, the optimization technique is very helpful to our research. Here, regression analysis of missionability parameters and approach we can give the input values and check the contribution ADJ, SS, ADJ, MS, FLU. These are the output values of the regression analysis. Finally, we will get the satisfied values. These are the graph. This is the 3D graph. It is plotted by regression analysis curve angle. Here in the regression analysis, we can touch with some point and we can change the particular thickness sense. It will give the easiest what is the output. We can easily identify it. So surface plots of output values of the 12 mm plate. See here, SOD feed pressure. These are the input values. We already whatever we given, this is taken, and these are the surface roughness MRR curve angle. These are the output values. This is the straight line. We know that this is the output of the regression analysis. We know what we know. SOD no, feed no, pressure no. These values are no. Okay, but we don't know about surface roughness MRR curve angle in the new thickness of the armor grade steel. But we know about the 12 mm, 16 mm, 20 mm, because we already working on that material. We get the results, but we don't know about changing the thickness of the armor grade steel. What is the MRR curve angle? We don't know. So in this condition, we go for optimization techniques, in the sense of regression analysis. So we can slightly move the straight line. At that time, he will show the values. Straight line in the sense we will show here. We'll change it. What is the surface roughness value? What are the MRR? What is the curve angle? So in this condition, we need to go further work for the don't go for the trials. Like the similar way, we can give the input for the 16 mm plate. This is the result, and this is the 20 mm plate. Regression analysis, we can work on it, and this is the 3D plot graph, and this one is the values for 20 mm plate. We change the input parameters, we can get the new output values. New output value in the sense MRR, curve angle, surface roughness. So this is the formula for that graph. We can enter into the SOD feed pressure. If you give the new values for the new thickness of the armor grade steel, if you should apply in the sense, we can easily get the curve angle. This formula is generated by regression analysis as per our input values. These are the MRR values, the regression analysis values. So if your publications, you not only do the experimental values, you can add the optimization techniques. Like regression analysis is a old technique, but we go for several ALML techniques. It's similar to this regression analysis, but the way is different. Optimization way is different, but the compared to accuracy, that AML accuracy is good as compared to the regression analysis, because regression analysis is the very basic one. So initial stage we tried. So if you are going to work with the machining process with a good publication, you can go with additionally add the optimization techniques by using network analysis or AML techniques. So these are the 60 mm plate for formula. This is the 20 mm plate formula. So outcomes of the experimental results. This work deals with one surface morphology of rolled homogeneous armor using abrasive water machining process. The main conclusions drawn from the present experimental work are summarized as follows. Feed is the most significant parameter to influence the surface roughness. Surface roughness varies proportionally to feed. Increase in pressure within the selected range improves the surface quality. Influence of SOD on surface roughness is least significant. The minimum surface roughness value is observed at a moderate value of SOD. The SEM analysis confirms that cutting wear mode in the initial, middle, and the bottom cutting regions due to the reduction in the particle disintegration. So this is a continuation of the outcomes. This broader work of surface morphology were carried out with 3 different parameters such as water pressure, driver, feed of jet nozzle, Standard of distance, short form of SOD. Surface roughness measured in the measured samples by meter to a surface roughness tester, and the miscibility of surface roughness is analyzed through scanning ultra microscope. It is found that abrasive water jet machine with the Gardner abrasive is the most significant factor related to surface quality process. Generally, in DRDO defense Savadi or another R&D department of the from the DRDO, they use the flame cutting process. From this research, we get the project. We can work on it the water jet machine with the missing of armor grade steel. Then they interested to buy the water jet machine. Now they buy the water jet machine, and now they work on the water jet machine for cutting process. Then go for the build the tank vehicles. So why we go for water jet machine? Say heat is reduction and the cut surface quality is good as compared to the flame cutting process or conventional machining process. If we go for laser, 20 mm thickness machine cost is very high. And the technical person also very skilled labor is required. Here, Fanuc code is using, and generally G01 normal coding is using. So easily anyone can easily comfortable with the water jet machining process. Thanks for your patience. Audience, any questions?
Thank you, sir. Dear participants, do you have any queries? Please ask with our resource persons or put it in the chat box.
Feel free to ask any simple questions also. Because water jet machine is currently very important for the mechanical department. It is a easy source for current research. Easy publications also very easily with using optimization techniques. Sivakumar sir asked which cost is effective of what AJM, EDM and water jet machine. The cost effective in the sense EDM is a cost effective. Second one is the WJM. Third one is the abrasive JM. Because EDM is very electrical one and very simple one, but the quality is not good as compared to the water jet machine. Second is the water jet machine. Here water jet machine is not coming with not mixed with the abrasive. So here only if we go for cost, our researchers don't focus on the cost because we need to focus on the quality. So quality is very concerning the cost. Because EDM is a very minimal cost with respect to the application. WJM is a different cost with respect to the application, and AJM is a different way is the application. Because the water jet machine having two types, basically water jet machine, and the second one is the abrasive water jet machine. Water jet machine is only used for glass and woodworks. Okay, and abrasive water jet machines used for cutting of high strength steel like armor steel, high strength low alloy steel, titanium steel, tungsten steel, and inconel steel like that. Another one is asked Nilesh Shane. Thank you for your questions. Can abrasive particles be recycled? What effect the pressure has on particle size? Because abrasive particles here not recycled because abrasive cost is very low. For example, garnet abrasive is a basic one and very suitable for all kind of thickness of materials, tungsten, titanium, aluminum. I hope, as per my research, as compared to silicon carbide, garnet abrasive, silicon garnet abrasive, because garnet abrasive is a very simple one. It is prepared from sea sand only. Okay, in sea sand, it is get from, so per kg is approximately 30 rupees per kg. So in this condition, if you go for recycle in the sense, what in the sense, because we're using the high strength steels in the sense, by using garnet abrasive, the MRR also already involved in the cut surface. So in this condition, the cutting powder also mixed with the particles. So it is recycled in the sense, the particle separation of garnet and iron particles is very, very tough to segregate. If we use it in that nozzle in the sense, the nozzle also affected, because the nozzle cost is high for what is it? Nozzle cost is approximately 2,500 rupees per nozzle. Okay, so it is not commercially available. We go to purchase to the same company, and we get from later only, because we order for nozzle, we'll get wait for 20 to 30 days, then only. So we can go for, we don't go for recycling, because the cost is very low, and the iron particles is easily mixed with the powder, because the mesh size is 177 microns garnet abrasive mesh size. So that is the reason. What next? What effect the pressure has on particle size? So particle size is increased, the cut surface also changed. If we increase the particle size, the cut surface also changes. So garnet having several grades of sizes. So 177 microns is acceptable one, as per we practical experience. So we increase the particle size, the cut surface also affect the cut surface. So you can choosing of the particle size of the garnet abrasive also play a major role. This one also important input parameter. So second one thing, Suresh Narayan sir asking, which parameter are more affect the water jet emission process? So in this condition, feed rate is play a major role. So if you increase the feed rate, so increase the feed rate is influence the thickness of the material. Sorry. So feed is the input major parameter is affect the water jet emission process. So suppliers are asking, what about surface finishes water jet machine? Here surface roughness finish is very good as compared to the flame cutting process or conventional machining process. Here don't go for secondary operations. For example, we go for flame cutting process. Initially we cut with the cut surface involved with the heat. Second, we go for milling process, because in flame cutting process the good surface is not achieved. So secondary operations required for machining process of the conventional machining process. If we directly go for vertical machine, then there is no requirement for secondary machining operations, because the surface value is 1 micrometer, 2 micrometer. It is easily we can achieve. So in this reason, surface finish is a very acceptable one for application wise. At the same time, cost wise also, because there is a reduction of machining time, reduction of manufacturing time also. Thank you. And the Sadish Kumar are asking, what materials can be effectively machined using AJM? It can effectively machine all grade of materials with respect to thickness. Titanium, tungsten, inconel, high strength, low alloy steel, armor grade steel, anything. Sorry, water jet machine having two varieties. First is a water jet machine. Generally, water pressures easily cut the glass material, wooden materials. But we can use the abrasive with water. We can easily cut the high strength materials also. High strength in the materials also. It is, but we can do the number of trials. Then only we can identify this parameter is suitable one. So next, Ashok Mas are asking, coarse nut particles are having more sharp edges, but finer particles are having smooth surface. Which one is more effective? So finer particles are having smooth surface. So finer sharp particles are most effective in the sense, because it is coming under mesh size, particle size. Whenever we use for very fine particles, we get the smooth surface. That is very acceptable one. It is an easy way to conclude the surface finish and the kerf angle. It's everything. The output value is also very good. Already I told that kerf angle is very it's a very having different varieties: positive, negative, taper. We need to get the correct cut surface. In the sense, we need to get the fine particles of abrasive we use it. In the sense, it is get exact values. It's the same particle size. Particle size in the sense abrasive materials, garnet.
Thank you, sir. Nice interaction. Any other questions, please? Thank you, Malkumar, sir. I would like to extend my sincere gratitude to you for your valuable insight contribution as resource person for this FTP session titled on machinability studies on HSLA steel by using abrasive water jet lake process. Sir, your expert insights, engaging presentations, and extensive knowledge in the field of machining and material science significantly enriched the participants' understanding of advanced machining processes. Sir, your in-depth discussion of machinability of HSLA steel and armor grade steel using AWJM coupled with his practical industry experiences and your research oriented focus that offered a profound learning experience for us. We greatly appreciate your effort in making this session a success and for inspiring the participants to explore new frontier in materials of engineering. Thank you, sir. Thank you once again, Dr. Vimal Kumar, sir, for your commitment to advancement of knowledge and for sharing your expertise research with us. Thank you, sir.
Yes, sir. Thank you, Dr. C. Manuel, sir, and the institution NPR College, and the all audience also. Thanks for your patience to watching my presentation. Thanks. We connect in the next lecture also. Thank you, sir. Thank you.
Sure, sir. Thank you. Thank you so much. Dear participants, please switch on your camera for video sessions now. Participants, please switch on your camera. Thank you all. We will meet on tomorrow session sharp by 6 p.m. For this session, feedback link available in the chat box. Participants are requested to fill the feedback link